List boxes in XAML are very similar to what you're used to. The list box enables users to select one or more items from a list of available choices. If the list can't display all of the items at once, because the window's too short, for example, then a vertical scroll bar appears automatically. You can add and remove items both at design time and at runtime, and the selection changed event occurs when you select an item. One of the primary differences between list boxes in XAML and list boxes elsewhere is that the list box and the list box items it contains are container elements. So you can put inside a list box text, images, stack panels that have images and text, etc. There are several ways you can populate a list box. You can do it in XAML. So in this example, we create a list box, and then there are list box items inside that list box, and the content property of the list box item determines what displays on the screen. You can populate a list box in code by calling the add method of the items property of the list box, and at design time you can also use the collection editor items dialog box. List boxes in XAML have familiar properties. Selected index returns the index of the first item in the current selection, or -1 if the selection's empty. Selected item returns the first item in the current selection, or null or nothing if the selection's empty. Selected value returns the value of the selected item. And because list boxes are containers, that selected item actually returns an element type. Could be list box item, could be image, could be stack panel, could be string, and we'll see in the demos how to account for each of those. List boxes have a selection mode property that determines whether users can select more than one item. It defaults to single, which means they can select one item at a time, but if you set it to multiple, then they can select more than one item. Each time they click on an item in the list box, it selects or deselects it. And then if you set this property to extended, users can select more than one consecutive or non-consecutive items at a time. So let's go see some examples of using list boxes. I have the Advanced Controls Examples sample application up and running. Let's take a look at list box examples. And in our first example, we're going to populate a list box in XAML. So let me move this over, get rid of these two windows that I don't need anymore, narrow this down a bit. I lost it. It's back. Narrow this down a bit. There we go. So my list box has a list of 5 AppDev experts, and in my XAML, the list box contains list box items, and I set the content property of each list box item, and that determines what gets displayed in the list box. And now when I select one of these, I need to know who I selected. So let's go look at the code that's going to run when I select a particular expert. I'll select an expert, and the selected index is 3. That's to be expected. It's the 4th item in the list, so selected index is 3. But selected item is not the name of the expert. It's a list box item. And that's because the list box contains list box items. When I click an item in the list, I'm actually selecting an element, which is list box item. And the value of that selected item is still a list box item. And so to find out who I selected, I take that selected item, which is an object, and I cast it to a list box item and then read the content property. So really what I'm doing is I'm getting this list box item and reading the content property, and then that's how I know that I selected Dan Wahlin. In our second example, we want to populate a list box in code. So let's move this over. I'm going to need to narrow it, get rid of this, and then get rid of these two. Here we are. So notice that in XAML the list box doesn't contain anything, and that's because I'm populating it in code. So let me go over here, select the code, and there it is. In the window loaded event handler, I call experts_listbox.items.add, and then I add the 5 experts. Now that's the same code that I would use to populate a list box in Windows Forms or Web Forms. And now watch what happens when I select an expert. Selected index is what I expected, but because I added strings to the list box, the selected item is now a string, so I can just read the name. Selected item and selected value are both the name of the expert, so I don't have to do any casting or anything, because when I populate the list box in code with strings, it contains strings. In our third example, I want to start looking at selection mode. And selection mode by default is set equal to single, and that means that I can select one item in the list at a time. That's the default. The second option I have for selection mode is setting it to multiple. And if it's set to multiple, then each time I select an item in the list box, I'm either going to select it or deselect it. And now when I click Show Selections, I need to know who I selected. So let's go take a look at the code for that. That is example 4. The selected items property of the list box is the collection of all of the items I selected. So for each item cast to a list box in that collection of selected items, I'm going to read the content property and then build a string. And then I add a comma and a space after each expert, and at the end, remove the trailing comma and string. And then the final example, which is example 5, has selection mode equal extended. And when selection mode is equal to extended, I can select continuous or non-continuous blocks of experts. So if I select an expert and hold down the Shift key, I select everybody in between the first and second expert, or I can select an expert, hold down the Control key, and select multiple experts. And then the code to figure out who I selected is the same. I loop through the collection of selected experts. So setting selection mode to single, which is the default, means I can select one expert at a time. If I set it to multiple, each time I click an expert, I either select or deselect them. And then if I set selection mode to multiple, I can select continuous or non-continuous blocks. So far we've seen examples of displaying names of experts in a list box, but remember, one of the benefits of XAML is that I can build better looking applications. So in example 6, rather than display the name of the expert, I want to display their picture. And now look at my list box. It doesn't contain list box items or strings anymore. My list box contains images, and the source property of the image element points to the location of the image. All of these images are in the images folder. So now what happens when I click on one of these, the selected item and selected value, since they're the same, is an image. And so what I now need to do in code is grab that image and read the source property to determine that I selected Ken Getz. Here's the code to do that. So I'm going to take the selected item, cast it to an image, read its source property, and then look in that source to see if it contains the string Robert Greene, Ken Getz, Don Kiley. These are the names of the images. And therefore, again, when I select Dan Wahlin, for example, I find the image element corresponding to that, read the source property, and I know that I selected Dan Wahlin. In example 7, I decided that instead of just displaying the expert's image, I would display their name as well. So if we look at the XAML for that, I now have stack panels inside my list box. And the stack panel contains an image and a text block. So when I select an image, I've selected the stack panel. So what I need to do is go into that stack panel and find the text block so that I can read the text property. And the code to do that is here. I grab the item I selected, cast it to a stack panel, and then the children property of the stack panel returns the elements inside that stack panel. So basically it returns the image and the text block. And then I can query this. I can use the ofType method and say, bring me back the children that are of type text block. And what that's going to do is bring back the list of all of the text blocks in that stack panel. Now I know there's only one of them, so I can say first or default, and now I have a reference to that text block, so all I need to do is read the text property. And then I know which expert I've selected. In the final example, I decided that instead of displaying the instructor and their name, I would display the picture and the full bio. So let's look at the XAML for this. It's very similar to the XAML we had before. This time, though, the text property is much longer, and I've set text wrapping to wrap, so the text would wrap. But now if I select Don Kiley, for example, I'm going to use essentially the same code to get to the text block. And what I could have done is grabbed the text and looked through the text, but I decided it would be more efficient to add a tag property that just has the name of the instructor. And so now, once I've found the instructor, I can just read the tag property. So what you've seen in this demo is how to display strings, images and strings in a list box and take advantage of the XAML containership model. And then you've also seen the code you're going to have to write in the selection changed event handler to figure out which item was selected in the list. The combo box in XAML behaves essentially as the combo box does in Windows Forms or Web Forms. It enables users to select from a drop-down list of available choices. And then a combo box contains a selection box that displays the currently selected value and the drop-down list. And then the users select values from the drop-down list. You can populate a combo box the same way you populate a list box. In XAML, in the Collection Editor Items dialog box inside Visual Studio at Design Time, or in code. And it has the same selection properties as the list box, and it uses the same containership model, so the combo box can contain text, images, and other elements. The combo box has two properties you can use to control what users can do with the text box portion of the combo box. The isEditable property enables or disables editing of text in the text box, and then isReadOnly enables or disables selection-only mode. So that determines whether or not the user can select text in the text box. Both of these are false by default, so you can't enter text or select text. To give the user the ability to select text in the text box, you can turn on isEditable. To give the user the ability to type in the text box, you turn on isReadOnly. Let's go see some examples of using combo boxes. Let's look at some combo box examples. And in the first example, we're going to populate a combo box in XAML. In the previous demo, you saw a list box used to display experts. Here, I have a combo box. So my combo box contains combo box items. The list box contained list box items, the combo box contains combo box items, and as before, I use the content property to display the experts. The user can select one, and then I need to know what was selected. The selected index is 2 because I selected the third item in the list. The selected item is a combo box item, so the selected value of that is a combo box item, and I selected Don Kiley. Let's go look at the code. This code is very similar to the code we saw in the previous demo for list boxes. In fact, except for the fact that we're using a combo box instead of a list box, it's literally the same code. So I grab the selected item, cast it this time to a combo box item, and read the content, and that way I know which expert was selected. Dan Willeen in this case. Okay, now let's see how to populate a combo box in code. Here's the XAML. And if I go down to where the combo box is, notice there's nothing in there. That's because in code, I'm going to populate the combo box with 5 experts. And because I'm adding strings, the selected item and selected value are strings, and therefore no casting needs to be done. In the third example, I want to look at the isEditable and isReadOnly properties. And that's because a combo box contains not only the drop-down list, but it also contains a text box. And so now the question is, what can I do with that text box? So if isEditable is false and isReadOnly is false, which are the defaults, I can't do anything with that text box. I can't type in there. I can't select. Now, I can hit the K key, for example, and select Ken, hit R to select Robert, but I'm not actually typing in the text box. What I'm really doing is selecting inside the combo box. So with isEditable equal to false and isReadOnly equal to false, there's nothing I can do with the text box portion of the combo box. But if I set isReadOnly to true and isEditable to false, now I come in and make a selection, and I still can't type in here or select from here. So because isEditable is equal to false, it doesn't matter what I set isReadOnly to. Okay, now let's set isEditable equal to true, and also set isReadOnly equal to true. Now, I can't type in here, but if I select somebody, I can select text in here. So I could copy this text from here. Because isEditable is set equal to true, I'm allowed into the text box, but because this text is read-only, all I could do is select from it. And then finally, if I set isEditable to true and isReadOnly equal to false, what can I do? I can select an item by typing. I can also type text that doesn't appear in the list. None of the above. And I can also select some of the text or all of it, cut, copy, and paste. So fairly subtle, but the isEditable and isReadOnly properties control what I can do with this text box. If isEditable is equal to false, then I can't get into the text box. If isReadOnly is true, I can only select text in there. If isReadOnly is false, I can actually type in here. When we looked at list boxes, we saw displaying images in the list boxes. We can also display images in the combo box. And the XAML for that looks like this. My combo box contains images. The source property points to the images. And the code I'm going to run to determine who I selected is this. So let's get that combo box back up. Narrow it down a little bit. Oops, wrong way. There we go. And now I can select an image, so I'll select Don Kiley. I take the selected value, I cast it to an image so I can get the source property, and then I check to see what's in there. Same code as before when I used list boxes. In addition to displaying images, I can display images and text. And again, as before, I have not only the instructor's image, but their name, and the XAML for that is this. The combo box now contains stack panels, and the stack panels contain images and text blocks. And so how do I know who I selected? I know because I cast the selected item or selected value to a stack panel, then I get the children of that stack panel, I query for the text blocks, I go to the first text block, and I read the text. Same code as before when we were looking at list boxes. And then finally, we can display not only the instructor and the name, but the full bio. And then when I pick one of those, I'm going to read the tag property of the text block, which contains the instructor's name. So that is in here. Each text block has a tag property, and I read that. So combo boxes work the same way as list boxes, with the exception of the text box. We saw how you can populate a combo box with strings, both in XAML and in code, and then with images and text. And we also saw how the code to determine which item in the combo box you selected is essentially the same code as you would use in a list box. You can use a tree view to display information in a hierarchical manner, using nodes that the user can expand and then collapse. You can populate the tree view in 3 ways, just as you could the combo box or the list box. You can do it in XAML. You can do it at design time using the collection editor items dialog box. You can also do it in code. And the tree view contains tree view items, which contain a header and then a collection of items. And then those items can be text, images and text, etc. Here's an example of how to populate a tree view in XAML. The tree view contains tree view items, and each tree view item has a header. So I have 5 experts in here, and I have 3 different groups. Experts whose last name starts A to G, H to R, S to Z. And so to distinguish between group headers and individual items, I add a tag. When you select a node in the tree view, the selected item changed event occurs. And then you can check in code to see if the user has selected a grouping node or an actual item node. And a tree view can contain text, images, other elements, just like the list box and combo box. Let's go see how to use a tree view. Let's look at examples of using the tree view. In the first example, I'm going to populate a tree view in XAML. And here's the XAML that populates this. My tree view contains tree view items. And I have 3 tree view items that are basically groups of letters, A to G, H to R, S to Z. And then within each of those are experts. So the tree view contains tree view items, and the tree view item is a container, and this tree view item contains 2 additional tree view items, 1 for each expert. Same thing for H to R, same thing for S to Z. Now in my code, I need to distinguish between whether the user has selected an expert, in which case they've selected that expert as their favorite, or they're just clicking the letters, which should cause the nodes to expand or collapse. And to do that, I've added tags. So before I cover this up, notice that the tree view items for A to G, H to R, and S to Z all have a tag set to group. And if we look at the code, I'm going to take the selected item, cast it as a tree view item so I can read the tag, and if the tag is equal to group, then I'll set the isExpanded property of the tree view item to the opposite of what it is. If the node is expanded, it'll now be collapsed. If it's collapsed, it'll now be expanded. If the item does not have a tag of group, then the user has selected an expert, and I read the header property of that tree view item because the header contains the names of the experts. Therefore, I know when I click an item, I know which expert I selected. In the second example, we'll populate a tree view in code. It's the same experts. Let's look at the XAML. The tree view doesn't contain anything because we're populating it in code. So in the window loaded event handler, I create a new tree view item, set its header to A to G, set its tag to group, and then I add 2 tree view items to that, one for Ken, one for Robert, and then I add that group of items to the tree view. Do the same for H to R, which contains Don, do the same thing for S to Z, which contains Dan and Doug, and now I have this tree view. And then the code to determine which item I selected is exactly the same. Now you may remember when we looked at combo boxes and list boxes that when we populated them in code, we were adding strings. But here, we're still adding tree view items, so the code in the selected item changed event handler is exactly the same to figure out which expert was selected. In the third example, I'm going to display images. And notice that when I click on the name of an expert, that expands a node, and that node contains their image. Let's go look at the XAML for this and get the tree view up next to it. So now I have a tree view item for A to G, that's this, and inside that I have a tree view item for Ken, and those both have tags, either a tag of group or a tag of expert. And then inside the tree view item for Ken, I have an image. The tree view item is a container. It doesn't have to contain only other tree view items. It can contain images or other things. And then because I wanted to distinguish between clicking on the instructor's name, which just expands or collapses their node, or clicking on their image, which selects the expert, him or herself, that's why I've got tags. And so if I look at the code, then the first thing I do is check to see, did you click a group or an expert? If so, expand or collapse. Otherwise, you clicked an image, cast the selected item to an image, get the source, and then look inside it. Now in this example, I decided that clicking the name of an expert expanded their node and that clicking their picture selected them as your favorite. I could have decided that clicking the expert's name actually selected them and displayed the picture at the same time. And in our final example, inside the node for each expert, I want to display not just their picture, but their bio as well. So let's go look at the XAML for that. So now the tree view items contain stack panels, and the stack panels contain images and text blocks, same as before. And the text block for each instructor contains a tag, which includes their name. And so if I click on this stack panel, then I need to go find the text block so I can read the tag property. And the code for that is pretty much the same code as we saw in the previous two demos. I get the stack panel, I get the children property, I query that to retrieve the text blocks, I get the first one, and then I read the tag property. And that way, when I click on an instructor's stack panel, either on the picture or on the text, then I can determine which expert I selected. So what you've seen in this demo is how to use a tree view to display information in a hierarchical manner. And you've also seen how to display not only text but also images in text. And then you've seen that the code you need to write to determine which item was selected is pretty similar to the code you'd write if you're using a combo box or a list box.